So today's video, we're going to talk about creating databases. It's not exactly the most exciting subject, but there's a lot of gotchas inside here if you don't know what you're doing. So in front of us, what we've got is a very empty shell of a SQL Server. This is SQL Server 2022. I am connecting to it from my local PC in my office down to a server I've got downstairs in my lounge. And what we're going to do is we're going to create a database, and specifically we're going to look at the things you should look at when you first create it. There's quite a few hidden little elements that, if you're not careful, can cause you quite a bit of a problem. So let's jump onto the box. So over here we've got already connected our server. As I mentioned, it's on SQL 2022, and all I'm going to do is do a new database. So inside here, what have we got? Well, we've got to give it a name. So let's call it training. And by default, after you've actually written the word training, you'll notice that both the logical names of the rows and the logs are pre-populated with the word training. You can change them. Don't really need to touch them. But what I would like to point out is that we have two rows here. One's called the rows data, and the other one underneath here is called log. I'm going to make this bigger just so we can talk about this. So every database has two distinct components. One of them is where your data resides, which is your rows data, and the other element is a log file. A log file is where all actionable elements which you do on your database are kept. Now, just to define what an actionable element would be, we are talking about inserts, updates, deletes. They're all actionable. Doing a select from a table just to return the results is not actionable. It is basically all the things that change data will be recorded to the log file. Now, in both instances, we have the opportunity at this stage to choose what size we want these to be. Now, they'll automatically start growing. However, if you know you're going to start off with quite a large database, then what you could do is you could actually start changing the size right here. So at the moment it's on 64 meg, which for a training database, I think is absolutely fine. However, you have two options. You can say that the growth is going to occur in percentage or in megabytes. So what does that mean? Well, at the moment, we're on 8 megabytes. I'm going to just go in here, and because my maths is so poor, I'm going to change that to 10. So we're on 10 megabytes. So in here, what I'm saying is every time I hit the threshold of 10 megabytes, SQL Server is going to immediately add a further 64 megabytes to the size of that database to accommodate the new data that's going in. But you have another option. You can do it in percentage. Now, never, ever, ever use percentage on production size databases. So we're on 10 meg at the moment. So 10% of 10 meg is going to be 1 meg. Let's say this is 1 gig. What's it going to be? Well, you can work out the maths there, 10% of 1 gig. And as you get bigger and bigger, 400 gig, a terabyte, how big do you need your database to grow? Now, in reality, when you hit these particular thresholds, these top points, you're not really going to need to jump 10% more unless you've got a really hot database, which is having thousands and thousands of transactions going into it every second. And even still, I wouldn't say that 10% is the right option. You define to me how busy a database is. During the night, it's going to be less. During the day, it's going to be more. Maybe during the night, it gets more at month-end processes. However, percentage is not a good indicator of allocation of disk space. Moreover, if you need to talk to your SAN administrator to get more disk space added, then percentage is a very relative term. I would prefer to always work in megabytes, so I'm going to leave it on 64. And then finally underneath it, we have got a maximum file size. It's set to unlimited at the moment, so it will just chew up the disk if you let it. There are particular reasons why you may want to limit the size of your database, but that's more of advanced DBA elements. So at the moment, we can leave it on unlimited. All these options are not going to harm the data that's inside there. Potentially it could if you limited your database and you ran out of space, but for our training, I'm leaving it on unlimited, and the file growth is going to be 64 meg every single time. So that's good. That's good. Now, the one underneath it is the log file, which is where I was talking about actionable things when I do a delete, insert, update, etc. By default, the log file will start off generally the same size as the database, which is going to be, well, now what I've said is I want it as 10 meg, so let me just do the same. I could leave it on 8 if I wanted to. It doesn't really bother me. SQL Server manages this, and it will actually start making the database, the log file bigger and bigger. The one thing within here, though, is the auto growth. Log files, depending on the backup strategy that you use, can get quite big. For example, I had a client where the backup strategy on their log files was once every day, and the amount of transactions going through on the system made that their log file was in the gigabytes territory very, very often, to the point that it ran out of disk space. What we do really want to consider is having a sizable log, and generally that log file should be on a completely different disk to where your data is. Which brings us over to the path section. By default, when you install SQL Server, there is a section where it asks you, what do you want your defaults to be? So any new database, any index, where does all this data actually go? Well, it's going to this particular path, which is on the D drive. Now, I just need to point out that this is the D drive on the server, not my local machine. So clicking on the 3 dots there will give you what's on the server's hard disk infrastructure, not your local machine, because it makes no sense. I'm using Management Studio on my local PC to instruct things on the server, so everything is server related. Now, after that, we've got a file name. Now, it's completely blank at the moment. If I leave it blank, it will fill it in for us, and it will actually create a training file and a training log file. And the default extensions are .mdf, Microsoft data file, and LDF, which is a log data file. So I'm going to leave them absolutely alone. Now, so far, so good. A lot of people, especially if you're in coding developers like C# and Python and people like that, they quite often just say, well, that's enough, click on OK and you're done. By and large, yes, you are done. However, test databases, development databases have a tendency to end up being productionized overnight. You know, that development database you've done, it's amazing. It's absolutely brilliant. We're going live with it tomorrow morning. Well, if you are working in that kind of environment, and I would say most of you are, I would take a few extra moments to go through some of the other settings within this screen, because you could paint yourself into a corner. And there's one in particular gotcha. So I'm not going to click on OK at the moment. What I'm going to do is go over to here, which is the Pages section, and I'm going to go to the Options page. Now, within the options page, there's multiple different elements inside here, some which you can change on the fly and some which are more permanent. None of these can be treated as once they're in, they're in. However, it can give you significant headaches. And the top one in particular, collation order. Now, collation order, really think about. When I click onto the collation order, by default, it's set to default. Again, collation order is one of the install settings. If I expand this, you will see that this scroll bar, this drop-down list, is particularly large. Chinese, Cyrillic, Danish, Estonian, French, German, Hungarian, Japanese, Korean. You can see it's just about got every language known to mankind in here. Well, of the people that would be using SQL Server. Now, what I'm going to do is I'm going to go up to the Latin ones. Now, Latin ones are generally the default English settings, but what we've then got is we've got Latin 1 general, and then we've got 100, and then we've got all these extra sort of letters after them. Well, what do they all mean? Well, I want to just pay attention to really one in particular, which is this one here, CIAS, very important. So what we're saying is we want the database to be in English. CI means it's case insensitive. So if you were to do a select statement on an employees table and you were looking for Fred, if I typed in Fred in lowercase, but it happened to be Fred was capital F, then it won't find a result. So it's very important you make sure that you get your collation order correct, because it can give you quite a bit of headache. Collation order as well, I tend to be on the camp of making it as loose as possible. Now, the reason why I say that is because of that very instance of Fred. If I type it in lowercase and it doesn't find it because it's got a capitalized letter, you're in pain. Moreover, you've got situations that if you had a front end to your solution, somebody may be entering this in through a dialog box, and if there's no mandatory or data inspection done on the commit of that employee being written, I could have Fred in complete capitals or in complete lowercase. I could also have it with some strange funky symbols in here, which would make it very difficult for us to actually inspect via a select statement. So case insensitivity is one I would like, but instead of CI, can you see a little bit further down, we've got CS, which means it's case sensitive. I don't want that. And the last one, AS, is about the default sort order of your data pages. Specifically, when we start putting data into our system, you're going to find that it's not really going to show anything. It's only when indexes start coming into play. By default, every index will be sorted in ascending numerical order. So you may notice, if you've ever seen suggestions for creations of indexes, it's always got ASC after the field name. That means I want it in ascending order. But by default, if your default is already on ascending order, I don't need to put ASC. The only time I ever need to put a sort order on is if I want an index in descending order. So by and large, it just means it can shortcut some of your commands. But ascending order and descending order is pretty important later on as you go down and enter more information on your system. For example, if you've got 50 rows and you decide you want to change it, well, that's no problem. If you've got 50 million rows, well, that's an outage because there's a lot of work for it to do behind the scenes. So collation order is very, very important. And also another bonus tip. The collation order is set at the database level. So as soon as I create my first table, it will use that collation order. So what if you set your collation order wrong? Well, if you set your collation order wrong, what will happen is your table being created will be on the wrong collation order. You go into your database properties and say, oh, I've made a mistake, and change the collation order of the database. It doesn't change your tables. So you'd have to go onto each table to change the collation order. And we'll see that when we get to table creation. So at the moment, I'm not going to select any of those. I'm going to leave them on default. Default because I've already got it set up to be case insensitive and ascending numerical or alphabetical order. Underneath that is the recovery model. Now, I'll just jump back to the general page for a second. You may recall I talked about the log file could grow quite large. Now, this is down to how the database captures the information. So if I go into options again, it's set to recovery mode of full, but you've got bulk logged and you've got simple. So what do these mean? Well, they deserve their entire video, but I'll just give you like the abridged version for now. Full means user transaction log. So any actionable piece of work, like you've deleted a record, updated, inserted, etc. that will be stored in the transaction log. Sure, the database will also have that change done to it, but it has a very important benefit. If I've got a full backup of my database, say Monday morning at 8 o'clock, I then insert at 9 o'clock 1,000,000 records. I update another 500,000 records at 10 o'clock, and then come 12 o'clock, some numpty goes onto the system and deletes all of the records. We got a bit of a problem here, because how do I restore it back to the point in time before that table was deleted? Well, recovery mode of full is your best friend, because you do your full backup first thing in the morning, and then every actionable item on your database is recorded to the transaction log. That means that if you did have a catastrophic data issue, you can restore back to your original backup and then apply your transactional logs as points in time. So it will then replay all of those actionable items up to a point that you have decided. And that is the benefit of using the recovery model of full. It's nothing to do with when you're writing data, it's in its name, recovery. How do you want SQL Server to bring back this data from the dead? Bulk logged is sort of a hybrid approach. What bulk log does is it doesn't capture everything. What it does capture is some of the big changes on your database. So by and large, bulk logs is like the mass inserts, the mass updates and so on. That's the bulk log element. Bulk logging is also quite useful for transactional log shipping. Super nerdy, not touching it just now. And then simple is the complete opposite. Basically, as soon as you've written something to your database, well, you've done an update, an insert, delete, stamped in the database. And the only way you're going to get that point in time effect is you'd have to back up every single minute of the day. On large production servers of terabytes of data, you cannot afford to do backups. These backups through SQL Server can take over an hour to do. So you can't afford to back up a large database very often. You need to back up out of hours and then just use transactional log backups to do that point in time approach. For our database, who cares? Let's leave it on full. I'm not really bothered. We can have a look at the log file later, I suppose. Now, after that, everything else is more of an optional extra. These other options can be changed on the fly after the fact. However, some people complain that they've got performance issues straight from the get-go, and some of this can be down to how it's been set up inside here. So what we've got is we've got all of these different properties. I'm going to just cherry pick probably just one of them for now, which is MAXDOP. MAXDOP, DOP stands for degrees of parallelism. And all it basically means is how many CPUs are you willing for SQL Server to use when it gets to the tough queries, when it has to do quite a lot of work. Well, the MAXDOP at the moment is set on 0, which means utilize every single CPU. Give me all the power you can muster, mister. And at that point, that's the best you can do. Now, the MAXDOP is directly related to your licensing model. So if you're on standard edition, it's generally up to, I believe, 4 cores. However, if you go on to enterprise edition, you can just license per core and you could have a beast 64, 128 core servers. And at that point, you may want to fine tune how many are allowed to do parallel tasks versus singular tasks. So for example, you'd never normally have this, but let's say you've got a really big database, you have thousands of users on your system, and you're also doing all of your reporting real time off that database. Reporting, selecting on multiple tables, can have a high cost associated with them, especially if your indexing strategy is not great. At that point, it's going to use a lot of CPU. But there's a lot of other transactions which go on the system which are very singular in nature, like insert one row, update one record. So at that point, they would be single processor style activities. So you may have a server with 32 cores. You may decide to actually reduce that and say, well, actually, I'm going to reserve 10 cores for other processes which would not normally go parallel. And it can give you a good balancing out, but it is an art form, not an exacting science. So that's what MAXDOP's all about. However, I will point out MAXDOP is controlled at a database level and a server level. So what I tend to leave is MAXDOP to being 0 on the database, but I would control the server's MAXDOP level, because that way then I'm ensuring that all databases follow the same routine. So the key thing inside here that I wanted to bring across was the collation order. Collation order does control a lot of aspects of how data is stored and how data is interrogated. And getting that step wrong at the very beginning can be costly. So make sure that you think about it, check what it is. If you're not comfortable what the default is, then by all means on the drop down arrow, find the one. If you just Google for SQL collation orders, the Microsoft tech page has everything to do with it. And we could be here for days reading it, and we're not. Now, we've talked about these first 2 pages. What about this last one, which is file groups? Well, let's go back into general. What have we got here? We've got a file group of primary. Now, if you had a 500 gigabyte database, 1 terabyte database, does it make sense for you to put all of your data onto one physical file, one path here? So we'll have a training.mdf file very shortly. If I had so many records, so much data in here, does it make sense that it all stays in one data file? Well, absolutely not. Your first reaction could be, well, if that disk blows up, we need to recover it. Well, yes, but your database backups do not consider your file groups by default. And also on top of that is that if one of your disks goes down, your whole database is gone. So backups are very important. What this is more to do with is throughput. How fast can I make my database go? So if I've got my database going across multiple independent disks, this opens up a lot of performance opportunities because it basically increases what's known as your IOPS, how fast data can be retrieved. Because if you think about your orders table, if it's spanned across 4 different independent disks and you're after data here, 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 and here, you can load them simultaneously. That also has the MAXDOP element because of the parallelism of the query. However, we've got to understand that small database is fine. One database is absolutely fine. But if it is a production-based system, you're probably going to want to have multiple files. So for example, what can I do here? Well, I've got all of this, but you'll notice down the bottom, I've got add. So I can just click add and I can just say, right, I want another one. And I'll call it training 2. By default, it is a rows data, but I've got log and file stream data. We're not going to touch that. I'm going to leave it on rows data. And now I can choose a different location. I'm going to leave it in the same place again, but I'm going to need to give it a file name, but I'm going to leave defaults and just let it do its thing. The final thing is jumping back to the file groups tab. Notice actually, both of these files, training and training 2, are on the file group of primary. So in here, you can see that primary is set to 2 files. So you can now logically group different file groups for different disks. So an example is you could have 2 databases running on your system. You'll have the primary file group for all of your production data and a secondary file group for test data. More importantly is you can actually start looking later on at database partitioning, where you have one massive database, but anything before the year 2000 you want on secondary data storage, which is slower disk. Out of the way, I'm not interested in it, which will then free up space on your production server. So partitioning generally goes hand in hand with file groups. So again, we can do this at a later date. You start off small, and as the database grows, you can then add file groups, then go back into general and then create further files, but then they don't go to the primary, they go to the secondary, and etc, etc. So you can then set up old data versus current data. So that's what file groups is about. And one thing just to point out here, if you are going to do multiple file groups, make sure, absolute gotcha here, make sure you've got them on auto grow all files. Now, the reason for that is, if I go back to general, I'm going to just say we've got it right here. I've got an initial database size of 10 meg, and then the one underneath it is on 8 meg. They're imbalanced. So what we want to do is we want SQL Server to fill the current 2 data pages full of data first before it starts growing the data pages. So what we're saying is I've got a total combination of 18 megabytes of free storage on that database until I need to grow my database. But at that point, I want them to grow simultaneously. So both files immediately get an extra 64 meg of memory. And that is what that tick box is all about. If you don't have that tick box turned on, it can cause performance issues because your CPUs going parallel are expecting your first file to be the same size as your second file. And if they're different, then you get a little bit of a sequencing issue. It's behind the scenes in the internals, but it's very important to try and get all of your files at an auto grow from the beginning. If you've got a database and it's not set to this, no worries, you can do it, but it would be an out of hours activity. You can rebalance if you decided to add an extra log file later, and I've done that on production boxes. So at this point we are pretty much good to go. We have got our database all set up, ready to go. So let's click on to OK and give it a moment, and there's our database. Now, I did mention about the MAXDOP setting. It's just worth just closing that particular point off, because if I right click on the server and go to properties, this brings up all the server settings, which is for another day. However, what we've actually got in here in advanced is if we scroll down, you can see that we've got a cost threshold parallelism and we've got the max degree of parallelism. Now, my server downstairs, I think, is 32 cores, so there's a lot of throughput the CPUs can do. So max degree of parallelism is set to 11. So that would mean my database, although I've set it on MAXDOP of 0, by default will have 11 degrees of parallelism, 11 different CPUs to work off. Well, sorry, cores to work off. So that's the important things with that. And that really concludes the database properties. Not a complete deep dive. Most of the other options will come into play when we start talking about performance or DBA activities. However, as an initial starting point of creating your first database, it's important to understand and burn into your brain things like the collation order. Collation order can make a big difference. So there's our training database. At the moment, it's completely blank. And what we're going to do next on the next video is we're going to start talking about test data. We're not talking about creating a full-blown fledged ERP or CRM system here. What we're going to do is we're going to create our own little database. And with that, we need data. And I'm going to give you some good tips on how to get data quickly. So till the next time, see you soon.